STIR is a set of protocols defined in the Internet Engineering Task Force. There are 3 key RFCs. Well, there's several others, but there's 3 key for the basic functioning of STIR. If you look at these, they're co-authored by Neustar, and this is kind of a second shot at this problem statement. So that's why the revisited piece. These standards define a security token, a mechanism for signing that token, having it certified by an approved or recognized certificate authority, and then actually transporting the information in the form of an identity header on the wire in SIP. The SHAKEN is really more the framework and an architecture that defines a profile or implementation for the service providers, and we'll get into more detail around that aspect of it, but it really forms the basis for end-to-end authenticating and verifying across traditional service carrier boundaries in the network. Really the analogy that I think is closest is that we're looking at existing standards that are out there and applying them to phone calls, similar to the way we've applied those to securing financial transactions on the internet. The phone network has become much more open to the internet, so we're applying those same kind of mechanisms to secure phone calls on as much of an end-to-end basis as possible. Next slide. A good way of looking at this is really kind of a layered approach. What this shows is the three layers. There's a call management layer, and this is what most people talk about. They just talk about the actual signing and the verifying of the phone calls, and that really is the real impacting aspect of this model for call time and actual calls being placed or coming into your network or egressing your network. The second level is the key management layer, and this is a set of functional components, again, defined in the standards, and this is actually where you manage the signing for the digital signing, as well as the requests of being able to have a approved or a recognized certificate authority sign your key materials, so that you can actually be a recognized participant in signing and verifying calls in the ecosystem. Since we are in operation with several carriers, we're functioning at this key management layer where the carriers are pretty much agreeing on mechanisms to allow signing and verifying and recognized certificate authorities, whether they're like self-signed by the carriers themselves or using a third party that is using a kind of pre-standard format of certificates, since the SHAKEN certificates actually require some extensions and some other aspects to be fully compliant. Now, the new layer here is the governance and policy layer, which is now moving toward implementation from an actual ecosystem perspective. We do have a governance authority, which is a governing board, but the policy administrator vendor as being selected in May, with a target implementation date of December 11th of 2019, and also a recent press release soliciting certificate authorities to participate in the approval process and in this actual governance structure for the US at least, just went out recently. We're looking at an operational or targeting an operational governance policy structure here toward the end of this year. That will require existing carriers to make some changes to adopt into that. But our joint solution supports both the key management with and without a governance and policy infrastructure in place, and gets much more complex when you add in the governance policy mechanism here. As you can see, just to walk you through that process, there's a key element, the service provider key management server. That is an interface between the policy administrator and the approved certification authorities. The arrows there are indicating a three-way handshake. So the first step in this process is that the service provider, which is operating these 5 green components, would be requesting a service provider code token using some identifier. Typically, we think it's going to be an OCN or a SPID type identifier. They will request to get validated and approved to join the ecosystem through the policy administrator. Once that token has been assigned, that token then is embedded in a certificate signing request with your private and public key that you generate or a third party generates, and then it actually works through an automated interface as well, a different one than with the PA, but an interface for managing the signing and validating of that certificate signing request, and then ultimately a signed certificate. And then as part of that process, there's validations that are done between the CA and the PA. So that completes the three-way handshake there for providing the actual shaken certificates that will be used in in a more broader deployment model.